Chapter 4, Capacitor and Inductor. This chapter is aimed to introduce various types of capacitor and inductor in the circuits. Students should be able to identify the types of capacitor and inductor, calculate the equivalent capacitor and inductor, draw the equivalent circuit for capacitor and inductor. You will be introduced with the basic concept, which is 7.1 series and parallel capacitor, 7.2 series and parallel inductor. A capacitor is able to store energy in its electric field. A large capacitor means that more charge can be stored. Capacitance is measured in farad with the symbol F. This is a capacitor construction, which is you can see that a capacitor consists of two conduction plates separated by an insulator. You can see that through the image as shown in this slide. So there is a dielectrics, and then being separated by an insulator, which is you can see that there is a metal plates that is connected in between the dielectrics. And then in terms of electrical diagram, as you can see that this is the plate, and then in between the plates is a dielectric, and then the voltage source or the current will flow through the plates, and then this is the constructions of a capacitor. When the supply is removed from the capacitor retains the stored charge. And then the amount of charge that the capacitor can store per volts across the plates is it a capacitance. For example, if the circuit consists of voltage source, as shown in the circuits, and then it connected with the capacitor. So and then the chargings or the charging diagram will be, first is, for example, if the volt is 10 volt, and then the capacitor will start to charging until it fully charged. So when it fully charged, the capacitor will be open circuit. So when the capacitor is open circuit, for example, the maximum charging will be equal to the 10 volt. So VOC will be equal to 10 volt. So the maximum voltage will be 10 volt. And then suddenly, if you are disconnected the source by removing the source in the diagram, it will act like a source. And if you connect with the load, for example here, load, RL load, the capacitor will act like a voltage source and then become a source to the load, and then it will start to discharging until 0. So this is charging, and then this is discharging. So hopefully you can understand the basics of capacitor. This is the symbol of capacitor. There will be two types of symbol, which is polarized and unpolarized. For resistor in series, when capacitors are connected in series, the total capacitance can be calculated by using formula as stated below. As you can see that 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3 until 1 over Cn. So the series capacitor is similar like a parallel resistor. And then for the parallel capacitor, where capacitors are connected in parallel, the total parallel capacitance is the sums of all capacitors in parallel. So C equivalent is equal to C1 plus C2 plus C3 until plus Cn. So for a parallel capacitor is similar like a series resistor. And then when you compare with the resistor versus capacitor, you can see that for the total resistance in series, you have to add the R1 plus with R2 plus with R3 and so on. But for the series, you have to do a 1 over C equivalence. So for the total resistance in parallel, what you need to do is 1 over R equivalence is equal to 1 over R1 and 1 over R2 and so on. As you can see that the total capacitance in parallel is similar like the total resistance in series. And then for the capacitor in series is similar like the equation for the total resistance in parallel. Here is the inductor. So inductors is able to store energy in its magnetic field. So inductance is measured in Henry, symbol H. An inductor consists of a coil of conducting wire with the length and the area, and you have to include the core materials and the numbers of turns. All these parameters will affect the values of inductance. As you can see that because of the inductor is depends on the coil, you can see that the symbol is similar like a coil. So when inductors are connected in series, the total inductance is L equivalent is equal to L1 plus L2 plus L3 and then plus Ln. So this is similar like a resistor. And then for a parallel inductor, when you connect it in parallel, so this is the parallel inductor. The equations is similar like a resistor in parallel. As for example, if the L1 is 2 Henry, L2 is 3 Henry, L3 is 4 Henry, and then I exclude the Ln. So the L equivalent will be L1 parallel L2 parallel L3. So therefore 2 minus 1 plus with 3 minus 1 plus with 4 minus 1, and then you have to minus 1 again, and then the answer will be 12 over 13, which is 0.923 Henry. As for the series inductor, take a look at this example. If I choose 1 Henry here, 2 Henry, and 3 Henry, so the L equivalent will be L1 plus L2 plus L3, 1 plus 2 plus 3, so the value will be 6 Henry. As for parallel capacitor, if I choose 1 farad, 2 farad, 3 farads, and then I exclude the CNs. So C equivalent will be C1 parallel C2 parallel C3 equal to 1 farad plus 2 farad plus 3 farad, which is 6 farad. As for the series capacitor, if I choose 1 farad, 2 farad, 3 farad, then I exclude the Cn here. So C equivalent will be C1 series with 2, series with 3, and then 1 minus 1 plus 1, 2 minus 1 plus 3 minus 1, and then you have to minus 1 again, and then the answer will be 0.55 farad.